Okay, this is Unit 5, Video 11, Stoichiometry, mole ratio. So what stoichiometry is going to allow us to do is it's going to allow us to convert back and forth from products to reactants, reactants to products, or even reactant to reactant and product to product if we have more than one product. So stoichiometry is really essential in chemistry because in the world, we're trying to produce things. You know, we want to know if I have this much of this reactant, how much product am I going to make, and do I need more reactant in order to make a product? So what we're going to do is we're going to kind of look at the relationship between reactants and products. So on the board here I have just kind of a simple synthesis reaction. We're taking phosphorus, reacting it with fluorine to form phosphorus trifluoride. So the key thing with stoichiometry that we need to pay attention to is the coefficients. So what these coefficients are representing is the number of moles we have. So while, yes, we have two fluorine atoms, this is a compound here. This is F bonded to an F. So fluorine bonded to fluorine. And I have 3 of those. So there's 3 fluorines. So what this is saying here is that in order to make phosphorus trifluoride, I have to have 2 phosphorus, or 2 moles of phosphorus, and 3 moles of fluorine in order to react. So what we can set up in order to predict products or predict how much we need of each is we can set up something called a mole ratio, which is just the relationship between the moles. So let's say we want to determine how many moles of PF3 we need. Okay, and let's say we start with 1.5 moles of phosphorus. Okay, so we're trying to figure out how many moles of phosphorus trifluoride will be made if we start with 1.5 moles of phosphorus. So first thing we need to do is what we start with always goes on the bottom because it's what we want to get rid of. What we want is on the top. So if we're in moles, we can go directly into the mole ratio. If we're not in moles, we have to first get into moles. Okay, remember when in doubt, convert to moles. So moles of phosphorus is going to go on the bottom, and we're going to have moles of what we want, which is the phosphorus trifluoride. Okay, now to get our mole ratio, we go to the balanced chemical equation. So if we look at the balanced chemical equation, we've got 2 moles of phosphorus, and we've got 2 moles of phosphorus trifluoride. Okay, well 2 over 2 is 1. So we form, if this reacts, we form 1.5 moles of phosphorus trifluoride. Okay, let's do another one. Let's say we want to know how many moles of phosphorus trifluoride are made if we start with 1.5 moles of fluorine. Okay, so we're going to do the relationship between the other reactant. I'm sorry, step 2. So, same thing again, we're already in moles, so we can go directly into our mole ratio. So moles of F2 needs to go on the bottom. And what we want goes on the top, so moles of PF3. Okay? Mole ratio, we go to the balanced chemical equation. So if we go to the balanced chemical equation, we need 2 moles of PF3. I'm sorry, yes, 2 moles of PF3 and 3 moles of fluorine. So when you multiply all of this out, you end up with, so you're going to take 1.5 times 2 and then divide it by 3, and you're going to get 1.0 moles of PF3. Okay, so mole ratio is just giving us the relationship between reactants and products in a reaction, which is the essential step in stoichiometry, because it allows us to flip back and forth between compounds.